So what we're going to be doing here is solving for equations when they're both in standard form. And when we solve for simultaneous equations, what are we doing? In this sense, what we're doing in all of this is we're finding x, y, which in this context is going to be the point of intersection of the two lines, if I were to graph them, which I'm not graphing them. I'm going to solve it with algebra. Let's look at our first example here, and we'll see if we can get an idea of it. Okay, suppose I have this system of equations, x plus y equals 6 and 3x minus y equals 14. My goal, when they're both in standard form, meaning x and y on one side and a constant on the other, is to try to eliminate a variable, to try to knock out a variable. And in this sense right here, if I were to combine these two equations, the positive y and negative y would cancel each other out. Okay, so that's our goal, to combine equations to eliminate one of the variables. So I go ahead and combine these. I can put a 1 coefficient here to know that, okay, 1x plus 3x gives me 4x. These guys cancel out, give me 0, and 6 plus 14 is 20. So x is going to give me 20 divided by 4 is 5. And then to solve for y, I'll just take that value of x and substitute it into either equation, but that one looks easier. So I can say 5 plus y equals 6, so y must be 1. Now this is the easiest type of a simultaneous equation. Easiest type because I didn't have to mess around with my first two equations at all. They're all set up. This goal is already there for me. And since we're talking about the point of intersection, when we write it as x, y, that's the point of intersection, if I were to graph it. 5, 1. Okay, let's look at another example where we have to do a little bit more, not much more. Okay, this one's, it's not that different because we go back to our goal. Is our goal there? Yes, it is, because I can cancel out these two guys right here. So I don't have to change anything. I can combine them right away. Put a 1 coefficient there. This gives me 4x. These cancel out. And 7 plus 5 gives me, what does that give me? 12. And I'm always going to highlight these ones green to show that that's our goal, to get those variables eliminated. X equals 12 divided by 4, which is 3. Okay, now I'll take that 3 and substitute it into either equation, but that one looks a little bit easier. So when I substitute x for 3, I get 3 plus 2y equals 7. So here requires a little bit of solving, because even though you substituted that 3 in, you still have to solve for y. Okay, so that's going to be, you subtract the 3, and you get 2y equals 4, and you divide by the 2, and you get your y coordinate. And of course, if we were to graph these lines, they would come together at 3, 2, wouldn't they? Nice whole numbers. Okay, before I go on though, back to our notes real quick. This method does have a name, which I forgot to write down. It is called the elimination method, and that is important to know because I will be referring to it. So when we talk about eliminating a variable, that's the name for. Okay, let's look at one more example. Okay, so here's a good one. So this one looks a little bit different because I have a bunch of coefficients and I can't eliminate anything yet because I've got different coefficients and nothing cancels out. So what I'm going to do is change one of the equations, and when I change one of them, I want it to look like this, like plus y minus y, or plus 2 and minus 2. I want them to be opposites. Okay? And when I combine the equations, I always add instead of subtract. So one thing I can do is I can look at all the coefficients and say, well, what will cancel out? Well, if I take this whole equation here and multiply that by a -2, that guy will change to a -6, and that's a +6, so then I will eliminate those. And it's important to put brackets around the whole equation so you don't forget to multiply this guy. So rewriting this gives me -4x minus 6y equals -4. And then you just rewrite the second equation. I don't need to change that at all because I have this going on. And now I can combine. And again, when I say combine, I mean addition. So we never combine until we have these opposite number coefficient things going on. So let's see what happens when I do combine. -4 plus 5 just gives me 1x. And -4 plus 1 gives me -3. Well, -3 divided by 1 is just -3 for my x. So let's take this x and substitute it into any equation you want. We have 4 to choose from. Which one do you want to put it back in? It doesn't matter. I just feel like putting it right back in there before I multiplied it by -2. It doesn't matter. So I'll say 2 times that -3 that I just figured out plus 3y equals 2. That's right. So multiply that. -6 plus 3y equals 2. And yes, these are a little bit more work because I have to solve for that y. 3y equals 2 plus that 6, bring it over, which means 3y equals 8, which means y equals 8 divided by 3, 8/3. 8/3 is fine. If you want to decimalize that, you can. So I'm just going to leave this as a fraction and write the ordered pair as -3, 8/3, because I don't feel like rounding that. And there we go. Okay. Lastly, we have one more type where we have to multiply both equations by something in order for this deal to happen. We'll do one more example. So with this example, I've got a bunch of coefficients, 3, 7, 2, 5, but I can't multiply one equation by something because I want to deal with integers, not fractions or decimals. And I won't. Here I could just multiply it by that -2 and get that thing going on, but I can't get that here with 3 and 7 and 2 and 5. So one thing to do is say, okay, well, why don't I work with 10 and -10 here to cancel out the y's? So if I want -10 and +10, I can multiply this by -5 and this by 2. Because that will give me there -10, and that will give me there +10. And you could have chose x. It doesn't matter which one you choose to eliminate. So now we rewrite both of these, multiplying that -5 all the way through. And I get -15x minus 10y equals, don't forget to multiply it there, -45. And I do the same for here, multiply that 2 all the way through. Okay. Now we are ready for action, of course, because I've got this going on. We combine the two equations. And we're careful when we do that, because -15 and 14 give me a -1x. And -45 and 40 give me a -5. So when you have this happen, -1x equals -5, that means x is just going to equal +5. Because -5 divided by -1 is a +5. So mistakes happen here. Use that value of x to I'll throw it into a different one this time. Why don't I put it into that equation right there to solve for y? 14 times 5 plus 10y equals 40. I get 70 plus 10y equals 40. Subtract the 70 from the other side, and I get negative 30. Finally, divide that by 10. Negative 30 divided by 10 gives me negative 3. Hopefully there's no mistakes in there. So my intersection would be 5, negative 3. And that's about as hard as they're going to get if all of our coefficients are integers. Okay? If they're decimals and fractions, you can do the same method, but it's a bit trickier. Okay, that's the notes for now. Those were a lot of notes. Good job. Round of applause there. That was good. Good job. Yeah. Well done. Well done.